In part D of example 9.3.4, we are given that the mean for the x is 795.46, standard deviation of the x's is 307.09, and we want a 95% prediction interval for the number of field goals made when a player attempts 1,000 field goals. We want to interpret our interval. So I'm going to go back and talk a little bit about the two formulas we have as our main ideas in this section, and they're very similar looking. In these two formulas, the only difference you'll find is that this one down here has an extra value of 1. Other than that, everything is the same. We want to think of these intervals as being one of two different things: a confidence interval for the average response for a particular x and a prediction interval for a particular x. So if we have an x value that we're interested in, which in the problem we're looking at is 1,000 field goals attempted, we can either think of a single person who attempted 1,000 field goals and trying to predict what the y value would be for that person. That is the idea of the prediction interval. Or we could think of all players who attempt 1,000 and what's their average y value. That is the confidence interval. And so everything's the same but that additional 1. Because that additional 1 is in there for the prediction interval for a single person, that interval will be a little bit wider. So what we're going to do is go through in this one, since we're talking about a prediction interval, we actually want this version for that one. We will work with the confidence interval in a later part in a later video. Okay, so we already found the y hat. We plugged 1,000 in part C, and we have our y hat value. We can pull some of the other values from the output we're given, and we're also given x bar and s sub x. So we have a lot of the info here. We do need to look up the t. Okay, so if we go over to our example problem, we do have our y hat value to start already. That was 465.432. We need to add or subtract our t. Our t star will use degrees of freedom of n minus 2. This example had 176. How we can tell that, or what we could look at here, is this output with some degrees of freedom. In our output, this number's n minus 2 and this number's n minus 1 for these degrees of freedom. So our n would be 176 and n minus 2 is 174. So we're using degrees of freedom of 174, and we're doing a 95% rate. So we need to look that up in StatKey. So this is already on the t distribution. We have 174, and then we click two-tail, and we get a value of 1.974. So we do plus or minus 1.974. Then the formula has the square root of our MSE value, which we can grab out of our output. So in our table here, we have our error row and we have our MS. So this is our MSE, 1369. So we can put that under our square root here. Then the formula has a 1 plus 1 over n plus, then we have this x star. What x star is in the formula is the number we're predicting for, and we're looking at a person with 1,000, minus the mean. We were given that here, 795.46. We square that difference, then over n minus 1, which will be 175 times s squared, and we're given s to be 307.09, so we would square that number, and then close off that big parenthesis. So this will give us 465.432 plus or minus 1.974, and then this whole big square root term should give you 37.1517. And I suggest you verify that before working on any of these on your own, that you're able to put that whole thing in your calculator correctly. So what we'll get for this interval is 392.0945 as a lower bound, 538.7695. So we're centered at this predicted value, but this is an interval that we're 95% confident in. So we're 95% sure that the number of field goals that would be made for a specific player who had 1,000 field goals attempted is going to be between about 392 and like 539. So somewhere in this range of values.